Okay. Actually, I want to talk about the connection between nutrition and infectious disease. And finally, I want to ask, why do only some COVID-19 patients die? So if we talk about influenza and flu, we're talking about two families of almost the same symptoms. On the left-hand side, you can see a bacterial infection, which you will see as bacteria and the biofilm growing on your tongue and on your tonsils. Or on the right-hand side, you will see a non-bacterial, which means viral. It can be coronaviruses, normal coronaviruses, and it can be influenza viruses and some other viruses. And usually you will not see a biofilm, you will just see an inflamed tissue, the tonsils and the tongue, and then later in the throat. Please read the disclaimer below. I'm not a physician or therapist, and I will give some advice here, which is absolutely voluntary. And anybody accepting anything that I advise to do, you can know that I do it with my own family, but it's on your own responsibility. Okay, so the hero of our story is a phagocyte. It can be a macrophage or a monocyte. There are several types, but this is our hero. It's a very large cell. It can be up to 20 microns size, and it swallows other pathogens like viruses or other bacteria or dead cells or phospholipids. It digests them and it excretes them as basically as a waste, and this waste are free radicals. And I'll try to explain the process that happens in an infectious disease. I'll try to take a very tough biochemical process and make it as simple as possible, and try to do it in 20 minutes. Even less. Okay, so what is common between beer froth and the human body? Foam. We are a foam of 100 trillion cells, and if you look at the microscope, in the beer foam or foam in your bathroom or on your body and any tissue in the body, you will see trillions and trillions of cells, and these are actually fat cells or lipid cells, lipid membranes, and the lipid membrane is the medium where the cell communicates with the external world. You have raw materials and for energy like sugar and water and minerals coming in and waste like CO2 coming out. And every inflammatory process happens in the cell membrane. It doesn't happen inside, it happens on the surface of the cell. So I tend to say that life happens in the lipid membrane. Disease happens in the lipid membrane, and the healthy membrane is the key for a healthy life. I'm not talking about genetic diseases. I'm talking about inflammatory and chronic diseases. And we'll soon see that also infectious diseases. So what is an infectious inflammation? So this is the cell, and this is the membrane. And the membrane is made of phospholipids. So we're in the lipid world. So most people know it's a double layer and it's very complex. And what is a viral attack? A viral attack is a double injury to the membrane. There are two steps of injury. First, the virus comes in contact and locks on the surface with these very famous spikes and ACE2 receptors, and it injures the surface of the cell. It either injects itself into the cell or it injects just its DNA or RNA, and it starts replicating inside. It goes to the nucleus and it harnesses the chemistry of the cell and the replication, and every cell will generate tens or even hundreds of viruses. And then the viruses will be excreted. They will escape the cell and again they will injure it. And when they injure the surface of the cell, they will liberate omega-6 and omega-3 eicosanoid phospholipids from the membrane. And this is what jumpstarts the inflammatory response. And this is true for any infectious disease. It can be bacteria, it can be a virus. So just a refresher on what the phospholipid membrane is made of and who are the key parts here. So these are phospholipids. So we have lipids here, right? Omega-6 and 3 and saturated fats, and the phosphorus group. So this is a diglycerol. We have cholesterol, which is not so important in this story, a very high content, about 15 to 20% of the membrane. and the lipids, and we have alpha tocopherol, which is a very important player here. It's between 1 to 0.1% of the lipid content. And we have the lipids themselves. So we have the saturated, which are about 22%, the MUFA, which is about 15%, and the PUFA, which are separated to the omega-6, ARA, so arachidonic, and we also have some others, DGLA, but this is the main one, about 15%, EPA about 4%, and DHA about 5%, if you're healthy, if your index is high. Now, there are three key players here in any inflammatory response, and this is the eicosanoids, the 20 carbon, arachidonic acid and EPA, and the alpha tocopherol. And I'll try to explain this play between these factors. So, which nutrient does a healthy membrane need? So we have a list here of foods that we can eat that will give us these nutrients, and I will try to show what they're important for. So the first one is vitamin E, only alpha tocopherol. It's the only one that can play this part in the game. And it protects PUFA, omega-3 and omega-6 in the membrane. It is not an antioxidant. It's a radical scavenger, capturing radicals from the extracellular fluid before they can penetrate the membrane and oxidize vitamin omega-3 and 6. And we get vitamin E from seeds and green leaves, or if you don't eat enough of this stuff, you can get it from supplements, so gel caps or a liquid. And it's very easy to get it, but unfortunately in the modern world, people don't eat too many seeds and green leaves unless they are health conscious like me. Vitamin A, especially beta carotene, and then the body can process it further to other carotenes. It sits physically inside the double lipid layer, and it protects from internal peroxidation processes. We all know peroxidation of omega-3 or of PUFA, in case that radicals do manage to penetrate. And we get vitamin E from all the orange vegetables. We get it from animal fat, liver, and fat dairy products like butter. So a very yellow or orange butter will contain a lot of vitamin A. And the last player, or not the last player, the next player is vitamin C. Vitamin C is a water-soluble sugar, and it acts as a weak antioxidant. It's not a powerful antioxidant in the blood. Its main role is to reduce oxidized vitamin E. I don't know if everybody knows it here, but it's a more important role even than being an antioxidant. And it helps, it recycles vitamin E to be viable and ready to work again. And we get vitamin C from many vegetables and fruit. There are very limited sources in the animal world. And basically, if you want to get it from animals, you have to eat the blood. It's the only place where you have high content on vitamin C. So either you drink the blood like the Maasai in Africa, or you eat liver or spleen where you still have a lot of blood. Vitamin C is considered a probable cause for COVID-19, and it's well known for many years, 100 years, that you can treat infectious diseases with vitamin C, and many of us take vitamin C when we have influenza, and it helps us to get over it quicker. There are two other nutrients which are very important. One is glutathione. It's not a vitamin. Glutathione is a water-soluble antioxidant. Our body manufactures it from glycine, cysteine, and glutamate. And unfortunately, we cannot eat glutathione, or I will call it GSH for short, because it's too complex amino acid, and it has to be decomposed in our gut or in our stomach, and we absorb it as glycine, cysteine, and glutamate, and then we make cysteine from methionine. And anyway, you can get it from foods, and generally people are not deficient in glutathione, because you'll be very, very sick if you have low glutathione. That's when you have a cytokine storm, that's when it goes down. And the last nutrient are the omega-3. And what is the role of omega-3 in the membrane specific? So we have about, a healthy person has about 8% EPA and DHA in their membranes. It can be a bit more, a bit less, depends how healthy, or depends on the tissue, but this is the average. And injury by a virus releases EPA to the extracellular fluid and activates an alarm trigger for the immune system, jump-starting the immune cascade. If you remember, when you release EPA, it is converted by COX and LOX enzymes into hormones, local hormones, which are eicosanoid hormones of the omega-3 family, and they start a cascade that ends up with inflammation, which is a positive thing. Omega-3 is not antioxidant, it's not antiviral. Some people use these slogans, it's not true. It acts as a signaling hormone for the immune system to act. EPA deficiency, if we have here in the membrane not enough EPA, causes arachidonic acid to be released in the membrane injury. Arachidonic acid turns on a hyperactive alarm signal, driving the immune system to autoimmunity. That's the big difference, that's the big problem. So in chronic inflammation diseases, there is always EPA deficiency and the hyperactive immune system. My company, Omega-3 Galilee, runs hundreds of, or even thousands of Omega-3 index tests, and we always see that people with chronic inflammation diseases, it doesn't matter which type of inflammation disease, they have low omega-3 index, and especially they have very low EPA. In summary, EPA deficiency is a precondition for autoimmunity and chronic inflammation. Many studies show low omega-3 index and especially low EPA in chronic diseases, and we know that omega-3 we can get either from fish or from fish oil. Okay, so what is a severe infectious inflammation? I will try to explain this series of how this happens. So let's start here with a virus that invades the body, and it can simply land on your tonsils and in your throat, coming from the air, like COVID-19 or influenza. You have antibodies, assuming you have antibodies in your blood, and later we will see that one of the problems of COVID-19 that nobody has antibodies, and it takes up to 48 hours to prepare the first antibodies. But let's say you have antibodies. The antibodies lock on special receptors on the virus, and they act as a signal for the phagocytes. The phagocytes have tentacles, these arms, these long arms, and they latch on to the antibodies, and they start pulling in and actually digesting the viruses. And the viruses are locked inside small stomachs, vesicles, and these vesicles, they fuse with what are called lysosomes. These are small vesicles that contain a very acidic, very low pH, like a stomach, acids, and they practically decompose the virus, or it can be a bacteria, or it can be dead cells. And eventually this phagocyte, this is why it has to be very big, because there's a lot of chemistry going inside. When it's finished its work, it decomposes the virus to its very basic molecules like superoxide and H2O2, and all these are emitted as reactive oxygen species. And this is the radical waste, and we find it in the blood because all this happens in the blood. And these radical waste, these radicals, they start attacking the membranes. And when they penetrate the membranes, they will decompose, they will attack the omega-3 double bond and also the omega-6, but first of all the omega-3, and this will start a chain reaction making peroxides in the cell membranes. So we have this circle going on, and when the membrane will decompose, you will have phospholipids released again, and parts of the membrane released into the blood, which will again be taken up by phagocytes and will release more ROS, reactive oxygen species, and radicals. And this is a severe autoimmune reaction, and this is what you call a cytokine storm. This is what happens in COVID-19. And if you want to ask questions at the end, I will explain why it doesn't happen on the first day, and it doesn't happen on the 10th day, why it happens after 2 weeks, and the sudden degradation. But that's not the main topic, but I have a pretty good picture how it happens. So if this process doesn't stop, you simply die. You die because all your tissues collapse and your tissues are disintegrated. Okay, so why don't we die from any infectious disease? We normally don't die from influenza. We don't die from viruses and bacteria. So what are the defense mechanisms? So this is a model of the membrane. This is the intracellular fluid. So this is a big, let's say 2 or 5 or 10 micron size ball, sphere. And this is the extracellular fluid. It can be the blood or the lymph. And we eat vitamin E, and the vitamin E is incorporated specifically in the PUFA areas if you know the structure of the cell membrane, there are PUFA concentrated area, and there are the lipid rafts. So this is the PUFA area. That's where you find the alpha tocopherol. Then we eat vitamin A, and it is incorporated within the membranes themselves inside. And now we have radicals, and the radicals try to attack the membrane. Actually, they don't try to attack anything. They just float in the blood, and they come there. And the vitamin E scavenges the pieces or the molecules of these, actually these protons. Now the vitamin E is neutralized because it's oxidized and it can't work. So we have vitamin C, which we also got from the food, from these vegetables and fruit. And the vitamin C has a higher affinity to these protons, and it takes them away from the vitamin E, and it floats in the blood. Normally it will meet glutathione, which our body manufactures by itself, and the glutathione, when it's oxidized, it will be excreted in the urine. You will urinate it. So that's how you actually get rid of these extra protons or these extra free radicals. And then the vitamin E is recycled and it can work again. This is why you don't get deficient in vitamin C in normal conditions. So everything is happy. So now I want to give you, this was a bit complex. I'll try to give you a block diagram of this to understand it. So this is the membrane. This is the oxidative stress, the free radicals floating in the blood, wanting to attack our membranes. We have vitamin A from the food. We have vitamin E from the food. We have vitamin C from food, neutralizing vitamin E and recycling it. We have glutathione, reducing and recycling vitamin C, and then vitamin C is ready to recycle vitamin E again. So these loops carry on all the time, and everybody is happy, and we excrete glutathione in the urine, and you can find it just in your urine normal condition. So this is a good situation, but when you are under a very severe inflammatory attack, this happens. When glutathione is overwhelmed and vitamin C is overwhelmed because this stress is too high, you start losing oxidized vitamin C in your urine, and your vitamin C level drops. And that's when you have this problem of an autoimmune reaction. Nothing stops, and this goes on and on and on. So to summarize, the first line of defense is vitamin E. Unfortunately, not enough people who are into nutrition talk about the critical importance of vitamin E. It has a bad name because of some stupid research that once said that vitamin E is a problem, but it's really not a problem. People are deficient in vitamin E. The second line of defense is vitamin C. The third line of defense is glutathione. And the last line is vitamin A in the membrane. And we actually see that people who die, for example, of measles, it's very rare to die of measles. But if you're deficient of vitamin A, you may die of measles. And that's a nutritional effect. There are other antioxidants which I didn't talk about, like SOD and uric acid, which work in the blood and inside the cells because there's a lot of oxidative stress in the cell. Vitamin E is critical also on the internal side. But again, on this talk, in this talk, I'm concentrating about infectious disease, which happen on the outside of the cell, on the external side of the membrane. So bottom line, why, in my opinion, do chronically ill patients die of infectious disease like COVID-19, but also influenza? So we know that in America, 10 or 15,000 people die every year from influenza. The numbers are disputed, but it's many people. So the first problem is if you have a chronic disease. When you have a chronic disease, you have chronically high oxidative stress, and you have a chronic injury to the cell membranes. This is when you have chronic inflammation in your joints, like arthritis or arteriosclerosis in your veins or in your arteries, sorry. And this is actually autoimmunity. Your body attacks itself. Then you are invaded by a pathogen, and the pathogen is attacked by the immune system. And then the oxidative stress increases even more. The antioxidants in the membrane, vitamin E and vitamin A, are depleted because cells start dying. And blood antioxidants like vitamin C and GSH are depleted. And finally, after 14 days of being sick with COVID-19 with 38 degrees or 40 degrees C, your vitamin C GSH levels collapse suddenly. It happens suddenly. And this is, in my humble opinion, the key event to disaster. This is when you get into this condition. It simply takes time to get rid of all your vitamins, and the fact that vitamin C, it takes 2 weeks. If you're in infectious disease, or you're under infection, it takes about 2 weeks to get scurvy. This is well known. So people who are healthy and don't have an infectious disease or infection can go on for a month without eating any food and any vitamin C. But if you have an infection, you die of scurvy after two weeks. So it really fits the model of COVID-19 in my view. So when this happens, the brakes on the oxidative stress in the immune system are lost. And that's when you have a widespread cytokine storm. Cytokine storm simply says somebody is signaling to the immune system, attack, attack, attack. And this somebody is arachidonic acid or omega-6 eicosanoids. And then the tissues disintegrate in organs under autoimmune attack. And we heard reports from hospitals, from doctors, that they see damage to the lungs, to the heart, to the kidneys, to the liver, to the spleen, and even to neurons, even tissues where you don't have any virus. The virus doesn't get to the neurons, and still you get an autoimmune attack there in COVID-19. So the patient basically, in my point of view, dies of scurvy. And that's why vitamin C is so effective. So what, in my opinion, causes high oxidative stress? Why do chronically ill people have high oxidative stress? So first, they have a low nutritional level of omega-3, especially EPA and vitamin E, just because they eat junk. They have a low nutritional status of vitamin C and A, and they use foreign substances that enter the body. And things like narcotic drugs, medications, alcohol, tobacco, vaccines are neutralized by cytochrome hepatic enzymes. And when these are neutralized by the enzymes, they also create radicals, free radicals, and this also increase oxidative stress in the blood. So consuming any foreign substance on a day-to-day basis, like smoking, increases your oxidative stress. This is very well known. Chronic drug use, I'm talking about the drugs which are medications like steroids, NSAIDs, cholesterol drugs, antivirals, antibiotics, and any other chronic drug increases oxidative stress. Autoimmune conditions and allergies treated by chronic drug use. So if you have a chronic allergy and you use antihistamines every day, intense and endurance physical activity increases oxidative stress. So if you're a football player, if you're a swimmer, if you're a marathon runner, you are more prone to this because you have much higher oxidative stress. This is also well known, and we've seen already that sports athletes have more severe COVID-19. Now, it's impossible to completely prevent infections like COVID-19, and any person in the above category is, in my opinion, at a higher risk for severe manifestation of the disease. So what can we do to prevent severe COVID-19 and other infections? This is the last slide, so Gerard, don't worry, I'm finishing. So first, before getting infected, just on your day-to-day life, get the following nutrients levels, required levels. Get omega-3 from fish or from fish oil. Get vitamin E from seeds or supplement with vitamin E, like 400 international units a day. Get vitamin A from colored vegetables, from liver, for animal and dairy fat. Get vitamin C from fruit and vegetables. Expose to the sun for vitamin D. I don't believe in supplements. This is a big story why vitamin D supplements, I think, don't work. Actually, I think they cause damage to most people, and I don't think they protect from COVID-19, but exposure to the sun does. Again, this is only my opinion. If there are vitamin E sellers here, please don't attack me, just my opinion. If you already got infected, and most of us will get infected by influenza or COVID-19 at some day in our life, then you can supplement with 5 to 10 grams of vitamin C a day. It's very safe. The type of vitamin C is not important. Most people can handle any type of vitamin C and absorb it well. Increase vitamin A foods and consider vitamin A supplements. In case of a severe infection, very high fever and prolonged illness, maybe you have very high fever or 39 degrees C for 3 or 4 or 5 days, then consider intravenous infusion of vitamin C. Maintain increased body temperature, hot drinks, hot baths, hot room. This is not a legend, this is true. Your immune system works better about 37.5, and viruses don't replicate above 37.5. They just, all the cell, it's not that the viruses don't replicate, our DNA doesn't replicate at high temperature. So your body doesn't grow, doesn't replicate, and the viruses also don't replicate. This is why a low temperature is so dangerous for viral infections, because the viruses can replicate very, very fast. It's 36.5. And to the medical staff, if they would talk to me, I have some friends, but I don't have any friends, doctor friends that treat coronavirus patients, so I only told it to my my family doctor. I would check vitamin C status on COVID-19 patients and consider giving them 20 to 50 grams a day. There were experiments done in China, very successful. I think there were experiments done in New York City with COVID-19 patients. I haven't seen the research yet, it was not published, but from testimonials that we have from doctors, I have doctors in the US that treat COVID-19 patients with these recommendations, including high-dose vitamin C, and none of them died or got severely ill. So it was not an RCT trial, but the testimonials of doctors accumulate, and it's already hundreds and maybe thousands of patients. So that's it. Thank you for your attention. Thanks to our hero, the phagocyte. And if anybody has questions for me, these are the ways to reach me. And I have a